and welcome to Realize Live. Thank you, Tony and the Siemens team, for the opportunity to be here with you today. And today, I'm going to take you on a digital engineering at Boeing. My name is Brian Carberry. Since 1916, the Boeing company has pushed the limits of technology around human flight and space exploration. And our company's enduring mission is to connect, protect, and explore our world. From connecting people to protecting nations, to exploring our universe, and also from the deepest depths of the ocean to the farthest reaches of space. What we at Boeing do changes the world. And our work is very complex. We have design and manufacturing methods that require high levels of accuracy and integration, as well as assurance and verification. And digital engineering is transforming our business environment. We are now seeing greater levels of efficiency and productivity, as well as quality and safety. And at the same time, we're also seeing reduced cycle times to market. So, the question, what is digital engineering? Well, it's arguably many things. Some say it's a methodology. We've got processes, tools, methods, applications, right? Technology. But digital engineering is also a philosophy. We have to understand our people and our culture and the mind frame in which we work. Digital engineering is a journey from our platforms to our production systems and to our sustainment systems. So I'm going to take you back a little bit on our digital engineering journey, a little bit before my time. We're going to go back to the 1940s. It is here in the 1940s, the Boeing company had a very transformational period of time. As you can see, we had mathematical equations on chalkboards. Those mathematical equations and chalkboards were then used as mathematical equations into this device. Interesting, is a computational analog device. It's actually Boeing's very first computer, and it was called the Boeing Engineering Analog Computer, the BEAC. Since the 1940s and to the 50s, transistors changed the world. And so the advent of computer-aided drafting and computer-aided design took place. So here you see an example of Boeing partnering up with, believe it or not, IBM on Boeing's first usage of CAD in the 1960s. Taking it one step further, we created our first, perhaps what we called our first digital human, and appropriately called Adam. And Adam was printed out on a plotter, and he was used to actually perform flight deck ergonomics and pilot simulations. So since the 1940s, the Boeing company, along with key partners, have pioneered the advancements of digital engineering. So now I'm going to take you to the 1990s. In the 1990s, what a great period of time. We had 3D wireframes. We printed some of those wireframes, so we had electronic drafting, computer-aided drafting. We also had solid models. So it was a very exciting period of time because we were getting into 3D. And these solid models had parametrics, they were associative, and they were relational. In the 2000s, this is what I kind of think of really Boeing's model-based design era. Here was the excitement. This was model-based definition in the 2000s. Now we had master models, and now we had solids, and we modeled everything, not just frames and wire harnesses, but we've modeled fasteners and washers and cotter pins. So mono detail. But what's interesting is in the 2000s, as we model this, some of you might relate. We actually had UG. Of course, UG ended up becoming NX. But it was this period of time when it was more than just the physical piece. It was the advent of a product data manager. You had the 2000s. Anybody know something about iMan? So we had iMan. And of course, iMan turned into Team Center Engineering. So Team Center Engineering was fundamental in our business. It was there that we were performing effectivity control, build-to packages, and of course, now we had VisView. We had VisMockup, and we were performing low-end visualization and doing daily design reviews using models. But then the next amazing thing happened in the 2000s. I think Boeing pioneered the advancement of model-based work instructions. In 2000, all of our new product design had model-based work instructions published electronic to the shop floor. In 2010, another exciting year. I now call this our digital engineering. So it was much more now than just a PDM. Now we had product lifecycle management. But we also had not just product lifecycle management, now it was the integration of many other systems. We were bringing in system engineering. We're also bringing in electronic design, wire harnesses. Also connecting our supply chain as well as our business operations. And the neat thing is we were ratcheted up, not just from low-end visualization, and now we had high-end visualization. This was Boeing's introduction. We developed and implemented Boeing's Immersive Development Center. It was a high-end virtual reality center that's still used today in our new product development. And it is here that we continue to use it for high-end virtual reality. And the neat thing is it's not virtual reality as a game. It's virtual reality with a real product in front of you. And so we were performing analysis and simulation of building the vehicle virtually. We also had, yes, Classic Jack at the time too. We had digital humans, so we have live motion capture, being able to reach for parts and make assessments. And it wasn't just design assessments. There were manufacturing assessments and maintenance assessments as well. So today, together with key partners, the Boeing company continues to remain a pioneer in the development and the integration of digital engineering in the aerospace industry. I want to introduce you now to the Boeing Digital Engineering Diamond. What Boeing has done is we've taken the traditional system engineering, physical design approach at the bottom, and what we did is we added the virtual modeling and sim on top. It is here we have the hundreds, if not thousands, of digital system models and digital twins. And being able to connect customer needs and desirements to operator solutions, we have our digital thread. And contained within that digital thread is not just our digital engineering, but it also contains digital manufacturing and digital sustainment. I'd like to introduce you to the T7. Introducing the T7A Red Hawk, 350 aircraft to the United States Air Force. This aircraft is purposely built along with ground-based training systems. It is here with the T7 that we took an entire model-based engineering approach. It is here on the physical side that we perform model-based definition, model-based work instructions, and we also did model-based tests. Our model-based testing supported the system validation and verification of our aerodynamic and load models. We saw a significant reduction in development time as well as our software time. And so today, not only can we apply digital engineering to new product development, it's great to share with you, we can apply digital engineering to legacy platforms as well. Introducing the new F-15EX Eagle II. With over 50 years of service, we are going to be upgrading avionics, increased payload, and increased fuel, and revised new internal structure. We have 80 aircraft going to the United States Air Force. It is here with the F-15 that we performed model-based definition and model-based work instructions, but we also introduced model-based quality. We're very proud of that. The F-15 ultimately had designed for maintenance and supportability so that we had interchangeability with this product. Again, significant amount of part reduction, quality, the engineering and manufacturing quality were increased. I'm proud to say that actually over 50% of this 50-year-old aircraft is now model-based definition. You just saw F-15, over 50 years old, right? So inserting digital engineering methods into legacy platforms has actually shown true design and manufacturing and maintenance benefits. So half a century ago, the two aircraft you just saw, the design of these aircraft were literally hand drawing. And so today, we're digitizing and creating digital system models and behaviors of these platforms. And this approach now, we're creating digital twins. So let me take you on a journey of digital twins. We have docking procedures and maintenance on the International Space Station. Docking operations, Starliner. Underwater operations, Echo Voyager. And these are all digital system models that have true behaviors behind the scenes. Simulating deck operations, MQ-25. Weather and environmental conditions, as well as airport simulation, 737. Hopefully that's not my flight going home. Takeoff simulations, 787. Approach landing, landing gear mechanism, wing bending, and gear compression simulation, 777X. Flight controls and avionics simulation, T7A. Launch simulation and takeoff performance, SLS, Artemis. The usage of digital system models and digital twins have allowed us to understand the performance and the behaviors of our products. The benefit of creating digital twins are enduring across the entire life cycle. And as we look at the life cycle, I want to talk to you real briefly about digital threads, because digital threads are key. Digital threads connect our digital system models together from the early stages of customer engagement with mission engineering, conceptual design, and system architecture, understanding that, then leading into the design phase of not just the flight science, but the physical piece, the electrical, as well as software. Here at Boeing, we use products like NX for the physical design, Team Center to help manage that, as well as Technomatics, and even Ops Center on the build side. But Boeing's ecosystem, as you see it there in the middle, that's a digital thread that we have, but we have to extend that. And extending that digital thread, we have to connect to our customer, we have to connect to our operators, and we also have to connect to our supply chain. In those connections, applications such as Mendix, Service Life Manager, and Supplier Collaboration Framework are helping us accomplish that. So our digital thread is key to really unlocking our future capabilities, as well as collaboration and the integration across the entire life cycle of the platform. Here's some future. So Boeing's story of digital engineering is still being written today, and it's so exciting. I'll be honest, even with 30 years of experience, the best is still yet to come. Our digital engineering is a journey, and I want to share a few thoughts with you as we've experienced them on this journey. Start now. Understand where your company is and where your capabilities are, and begin to incorporate those. When you start with those capabilities, begin to perform iterations around those. Understand what those iterations are doing and collect the knowledge and the key decision points. When you perform those iterations, continue to explore and insert new technologies and new applications and new integrations as you're bringing those iterations together. But be mindful. Don't think technology alone will do it. Please invest in your people. You have to understand the framework. You have to understand the mindset of your company and your people and your culture. And more importantly, understanding your organizational readiness. And lastly, develop partnerships. None of this could be done if you do not develop partnerships. I'm proud to partner with the Siemens on Boeing's digital engineering journey. I've shared with you Boeing's digital engineering journey from the past the present, and the future. Now, I leave all of you with one final question. What will we dream of next? Thank you.